Welcome to homework.
So in this problem, we're going to do some mathematical manipulation with the deceleration parameter, which no longer is talked about because we know that deceleration is not what's happening to the universal expansion. Instead, acceleration is. But we're gonna work with the deceleration parameter here, and then also the density parameter omega, and the Hubble parameter h. Hubble parameter h, all right, and deceleration parameter is q. That's what we're working with here. And so we start off with the equation deceleration parameter time t is given by minus r scale factor times d squared r acceleration. And so that's d squared r over dt squared, second derivative, divided by the square of the expansion velocity dr dt squared. All right, and so let's look at the numerator and the denominator. So from equations 51 and 11, we get that q of t is equal to minus r times minus 4 pi g over 3 times rho times r. And so this is equation 51. This is the case that p equals 0 in this universe, divided by equation 11, which gives us that dr dt squared is equal to 8 pi g times rho for 3 times r squared minus kc squared. And so we can manipulate both of these. Let's look at the denominator first. Denominator, and so here you're going to manipulate this to look like something we want. So we want this in the form of omega, and so 8 pi g rho over 3 is basically you multiply h squared on the bottom here, and that's equal to omega. And so therefore what you have is omega times h squared, and the r squared remains, right? 8 pi g rho over 3, that's omega, and then we multiply and divide by h squared. That's where the h squared comes from, and r squared remains, minus kc squared. Look how simplified that looks now. And then from equation 24 in the book, it has to do with h, omega, and r, and k. We have that h squared omega squared is actually kc squared over omega minus 1. And minus kc squared, you take kc squared as the common term. You have omega over omega minus 1 minus 1. So this comes out to omega minus 1 in the parentheses, divided by omega minus 1. The omegas cancel, and you are left with the denominator term becomes kc squared over omega minus 1. Great. And then I'm going to use a different ink for the numerator here. The numerator, basically you once again use omega. You have 4 pi minus 4 pi. You basically have 4 pi g r squared over 3 times rho. All right, and so this one can also be manipulated. Here you have omega over 2 times h squared r squared. And remember, omega is just 8 pi g rho over 3h squared. And so you multiply and divide by h squared. And since it's 8 and not 4, you have a factor of 2 here on the bottom. And r squared, once again, is not dealt with. So omega over 2 times, once again from equation 24, here we came up with kc squared over omega minus 1. Therefore, we put it all together in red here. Therefore, Q of t is equal to omega over 2 divided times kc squared over omega minus 1 divided by kc squared over omega minus 1. Therefore, these are canceled, and you're left with Q of t, the deceleration parameter, is equal to 1/2 of omega of t, the density parameter. And that's it.